but that's okay. The paste command automatically extends the bosses down to match the curved surface. I want to use information from the blue part to help me modify the light cyan part. I just hover over the bosses and its information is projected automatically up onto my work plane, which I can then use to create my profile for the modification. I'll go ahead and punch this profile through the light cyan part. Although the bosses were created at the same time, they are completely independent of each other. I can change the height of one of these bosses to be shorter by about 2 millimeters. If all of the bosses need to be adjusted, they can be changed independently, or you can define a relationship so they all grow or shrink at the same time. I have some new information about the target size of the media player, and it needs to be shorter, so I'll change both parts at the same time. As you can see here, we're changing both parts in one step, even though they are completely independent of each other. Let's change the blank part into a simple representation of the PC board that will fit into the base. This gives me a part to use while I wait for the model of the actual board. You have seen direct modifications to the model using the 3D Copilot. However, some people prefer to use dimension-driven changes. I need to further reduce the size of this part, so I'll add some dimensions to make those changes. You can use dimensions just like any other selection. The dimension is just another way to help define the change. In this example, we're going to make a major design change by moving lots of features driven by the overall length dimension. You can see from the side view that it may be more visually appealing to have a change in thickness from the top to the bottom. Let's try that by moving the underlying surfaces a few millimeters to the right. Here you can see that we're manipulating two of the underlying surfaces in the model to radically change the shape of the part. We just grab the faces and move using the 3D Copilot. I need a way to secure this part to the front cover. I have another design with a snap feature that has been proven and is reliable. This file comes from a vendor that uses another CAD system, but that's okay. I can load the IGES file of the part and leverage the snap feature from that part. I'm going to copy the feature, and you can see that it recognizes it as a rib feature, and position it in the correct location in my part. I'll go ahead and copy the other rib feature and position it also. Notice how the features extend through the model. This is okay, as the software will automatically correct this when we paste them onto the model. And all blends and adjacent faces will be updated as needed. I just learned that I need to make more space to access the battery and the memory card slots. Rather than a small snap-in cover, I'll consider an access cover that slides in from the top of the device. To improve the appearance of the access hole, I'll add a couple blends, and I'm going to leverage an existing surface on the part to create a more curved shape for the access hole. Notice how we can leverage the shape of one face, specify some modifications, and apply it to another face. The battery is larger than expected, so I need to increase the width of the access slot. Again, using the automatic feature recognition, we're able to select the slot feature and make it 1 millimeter wider. And finally, I want to round over the sharp corners. So I select the edge and add a couple blends. I'm going to load in the rest of this assembly, the front cover, which has been saved into Model Manager. I can load it and position the case to it to review our progress. Here I'm positioning the case part to match up the boss standoffs to line up with some features on the front cover part. And finally, we'll mate the planar surfaces together. Co-Create modeling is flexible, so you can quickly and easily create 3D designs and change models through on-the-fly interactions with geometry. The lightweight and flexible approach is ideal for companies whose products consist of one-off designs. You'll save time by having the highest level of flexibility in the design process. You can respond to unexpected and often unpredictable changes throughout all the design phases. You aren't restricted by information that is captured and embedded as part of the model definition. For companies who face this challenge, whose designs change drastically from conceptual to final design stages, Co-Create modeling provides optimal flexibility.
Thanks for watching PTC's Demos and Tech Tips. Work smarter, not harder.